So we have a concrete block of mass 35 kg is pulled along a horizontal floor with the aid of a rope inclined at an angle of 30 degrees to the horizontal. If the coefficient of friction is 0.5, so in the question we have mass 35 kg. So we have coefficient of friction 0.5. Calculate the force required to move the block over the floor. So now we need to sketch the diagram. Here theta is 30 degree. So now a concrete block of mass 35 is pulled along a horizontal floor. So let's say this is my horizontal floor. So a block of mass 35 kg is pulled along the horizontal floor with the aid of a rope inclined at 30 degrees to the horizontal. So if this is horizontal, so the rope inclined at an angle of 30 degrees. So let the force on the rope be T, so tension. So now there will be a vertical force also. So if this is tension T, then this is the horizontal component. So here is T cos 30 degree. Why this place will be T sine 30 degree. So if you watch my video on scalar and vector, I told you that where the angle lies is always cos. So this place is cos, then the other side is sine. So if you watch the video on scalar and vector, you will understand better. Now, if the coefficient of friction is this, so that means frictional force will be acting this way, Fr. And Fr is mu r, coefficient of friction. Note that the weight of this object will be acting downward. So weight is mg. That means weight is 35 times 10. If our weight is 10, g is 10. So weight will be 350 Newton. That means this place is 350 Newton. Now there is another force that will oppose this, which is called normal reaction. So this is the sketch of the question. So as weight is acting downward, there is another force acting upward, that is normal reaction. And this one is as a result of the component of this tension. So the tension T, the force on this rope, is inclined at an angle of 30 degrees. So it will have both horizontal and vertical. So that is the component. So if you read the question, that is it. So a concrete block of mass 35 kg is pulled along the horizontal floor with the aid of a rope inclined at 30. So we use this rope to pull this block along horizontal. So that is just the interpretation. So now let's find this tension T. Remember, summation of all the forces in the horizontal direction must be 0. That means T cos 30 minus mu r is equal to 0. That is, this mu r is opposing this T cos 30. Those are the horizontal forces we have here, T cos 30 and Fr. So that means T cos 30 minus mu r should be equal to 0, since the block does not have acceleration. So that means T cos 30 is equal to mu r. But we know mu already, which is coefficient of friction, is 0.75. not 0.5. Coefficient of friction is 0.75 is in the question. So now this is for horizontal force. So this is equation 1. So let me substitute T cos 30 equals 0.75 R. So call this equation 1. Again, summation of all the vertical forces must be 0. So the forces that are acting vertically now are R and T sine 30. So now that means this will be R plus T sine 30 then minus 350 is equal to 0. So because this 350 is acting downward, so now R is equals to 350 minus T sine 30. Call this equation 2. Now anywhere you see R in equation 1 here, put this value there. So substitution method. So that means from equation 1 now, T cos 30 is equals to 0.75. So instead of writing this R, I'll write all this expression here. So that is 350 minus T sine 30. So now we need to open the bracket and collect like terms. So open the bracket and collect like terms. This will give us T cos 30 equals to 0.75 times 350. So that is 262.5 minus again 0.75 times sine 30. We are expanding, so that is 0.75 sine 30. That is 0.375t. So now press cos 30 also. So that is 0.8660t equals 262.5 minus 0.375t. So collect like times now. 0.8660t is equal to, so move this one, that will be plus 0.375t. Everything is 262.5. So add now 0.8660 plus 0.375. So that is 1.241t is equals to 262.5. So now t is equals to 262.5 divided by 1.241. So t is equals to 262.5 divided by 1.241. So that will give us 211.52 Newton. So that is the final answer. So that is the force that we can use to drag this block at an angle of 30 degrees to the horizontal.